Right. Welcome everyone to this talk by Eric from Zalando. We're super happy to have Eric here. He's been a really big part of the Scala community now for the past 10 or so years, I would say. Yeah. So he's one of the authors, or he's the author of the F effect monad for Scala, as well as the specs2 library. Please give a warm round of applause for Eric.
Thank you. You hear me? Yes, thank you, and I hope you have a good lunch. Thanks a lot for inviting me. I'm very excited to come here in Stockholm for the first time and talk to you about Haskell. So I work at Zalando, and Zalando is a huge website for fashion in Europe, selling lots and lots of articles. And we have lots of software engineering behind this platform, right? We have like the website, but there's also all the logistics part. We have some warehouses, and all the software inside the warehouses is being developed internally. So that's lots and lots of engineers working at Zalando. And in my part, I'm in the department where we actually take articles coming from partners, and where we onboard those articles so that they can sell their own articles on the platform. Because, hey, we have a platform, why not use it? But today I want to know a bit more about you, maybe. And can you raise your hand if you're using one of these mainstream languages daily? OK, and now raise your hand if you're using something completely different that I've never heard about. That's really cool. What is it? Erlang. It's not on the screen. Oh, I put Elixir. Does that count? Not quite. OK, not quite. The green here is supposed to be JavaScript. Okay. So maybe that's the one you're using. OK, so actually, these days, I'm not using, most of the time, not using one of these mainstream languages here, but I'm using this one, this strange language called Haskell. But I mean, I didn't come to Haskell completely by accident one morning. It was like the result of an evolution that maybe many of you are following the same path at the moment. And when I started programming, I started programming for one of these things. And so this thing is called a PIBX, made by Alcatel in France. And so this is how you deal with many phones in companies or hospitals or hotels. You need a machine to deal with all the functionalities you can have for those phones, right, to manage those phones. And those systems are actually quite complicated. And they are so complicated that they need a software to just configure the box you are selling to a given customer. So based on the customer need, you have a full software trying to determine what to put inside the box, where to put the cards. There are many technical constraints and so on. So this was my first project, and it was in C++. And yeah, C++ was a fairly used language at the time. And, but this software had a huge problem. The core of this software was one huge, gigantic method having 2,000 lines. That was the core of the software, just one big method. And of course, they could not develop anything anymore. It was too complicated. So I was tasked with, simplifying the whole thing. And even before simplifying the whole thing, I started by just writing specifications. And I guess that's where my love for specifications came, that for 6 months, I didn't even touch a line of code, just writing specs to actually understand what it was supposed to do. And then I started refactoring it. And I was super happy because I was like fresh out of engineering school and had this wonderful tool that I've been taught, which was object orientation. And I've been taught that objects are amazing. They can do everything. You can model the whole world by just using objects, right? They send message to each other. They have inheritance if you want to factor out some behavior that is supposed to be shared between objects. They are a great design and engineering tool. And I was super happy to use that tool. And at the same time, there was something called UML to model the software. And I was thinking, oh, OK, maybe the software is complex. And one way to tame this complexity is to represent it. Use images, use diagrams to better understand what's going on inside the software. So with those two tools, I and the rest of the team worked to refactor the software. And patiently, we were indeed able to extract useful concepts, like make the difference between what's on the card and what can be on the card. That seems simple, but making this distinction made a great difference. So at the end of the project, it was a success. We refactored it. The software was able to evolve. We had nice diagrams, and I was really happy. Like my first project, 100% success. perfect. And I have this methodology like OO, and I think I can conquer the world, because what can I not solve with OO? And then I started my second project, and that's where my trouble started. Things became harder all of a sudden, and not only harder, but very much harder. Because the second one was about using J2E in the telco environment. J2E was very new, and it was still with this object mentality that objects could do everything. They could do persistence. You could annotate them to do transaction. You could do lots of things with just an object. They could communicate with each other, and that was supposed to be such an easy way to represent any kind of system. And this failed miserably. That was really, really difficult. And then I had other projects, and over maybe this like 7 years that spanned my life as a software consultant, I realized that my success rate was like more like 50%, not 100%. It was kind of depressing. And I must say that many of these reasons are not necessarily related to programming languages or technology, but just sometimes to project management. And so Agile was picking up at the time, and that was kind of a good thing. But it was still depressing. So I started wondering, okay, maybe there's something I can change. Maybe I need to investigate for other things. And I started looking at other programming languages. What do they have to offer? Why are people even interested in other programming languages? So I read like the Pragmatic Programmer's book, and they talked about this language coming from Japan called Ruby. Okay. And then I realized, oh, wow, it's actually nice what you can do in Ruby compared to Java. You can code some things, like you can filter a collection, collect all the elements you really want, and then output a result. That's a change. In one line of code, I can do so much more. And as I was also reading on testing literature, I knew that one of the heuristic of, an empirical result of testing literature is that the less number of lines of code you have, regardless of the language, the less bugs you have. It's kind of a very mechanical relationship between the two. So I was thinking, okay, maybe just having less lines of code will mean less bugs, will mean more success. And around the same time, there was this other language which was closer to what I was doing, which was Groovy, and it was on a JVM. And it was doing very similar things and having like first-class functions. And so I was truly amazed. Like it was a brand new world opening up to me. And now I can develop much better software. Why no one ever told me about this before? There are those things. Wow, we should use them all the time. There was some slight inconvenience, though, something that was really, really annoying me. No types. And I mean, every time you have a substantial piece of software, I found out that having no types was a real pain, really, really painful. And coming back to a Groovy project 6 months later, it was just grabbing some logs, doing some statistics, and so on, was a major pain. I could not even understand what I was doing before. So I said, I need to find something having more types. And Scala was a great compromise, right? First-class functions, collections, types, runs on the JVM. It's like the perfect choice for what I wanted to do. So, well, started learning Scala, discovered some new concepts like pattern matching. We'll talk about that later. And then eventually Haskell. So in a way, after going through all this journey of doing Java, C++, Ruby, whatever, Scala, Haskell, I realized one thing is like, wow, Haskell is not such a new language. It's like 25 years old. And it seems like it's a very niche language. But actually, if you look back on all the other languages, it has a profound influence in everything that's being done in mainstream languages right now. So it's a very long introduction to tell you that today I want to show you how Haskell is really influencing us and how functional programming is having a deep influence on what we do. So what is Haskell? So this is Michael Snowman. He's a very well-known Haskell developer. He's provided maybe half the ecosystem of the Haskell libraries, and the rest is AltMet. And this is how he describes Haskell with a few properties, functional, types, garbage collected, and so on. And I want to keep like 2 major properties from Haskell that makes it a very, very distinct language. So the first one is that it's a lazy language, meaning that when you have an expression, if you don't ever need it, it's not going to be evaluated. It seems a bit trivial, or maybe you can be indifferent to this kind of property, but after a while, you realize that it's a nice property. Like, you write an expression, and you never have to wonder, oh, shit, is that thing going to be evaluated or not? Because maybe it takes a lot of computation, and you kind of think, actually, I don't care. If it needs to be evaluated, it will be evaluated. So it kind of changes the way you program. But the main reason why they wanted the language to be lazy is that it forced the language creator to keep the language pure. So what does that mean, pure? That means programming just with pure functions. So a pure function is like a very mathematical function, something where you give it an input and it gives you always the same output. So that means it cannot depend on anything and any state that you would grab from a database, from the file system, from an environment property, whatever. And the output is always going to be the same, and it's not going to print different things to the console and so on. And that makes software kind of very predictable and very understandable, because each expression in isolation, you can understand it. It does not depend on anything else, and you can refactor it, you can move it around without fearing of breaking anything. So it's a great property. And it's actually also not so obvious to program with only pure functions, because we do side effects all the time. When you program, we have effects. We need to write to databases. We need to take inputs and so on. So that forced also the Haskell implementers to come up with new ideas, like, oh, maybe we can use monads for this. And that's triggered a full industry of new concepts and new ideas. That was great. So this concept of just programming with functions is very deep. And I find something funny is that in other mainstream programming languages, this is rediscovered all the time. So you have blog posts like this, like, hey, in Java, look at that. We can have pure functions. They're great. They just depend on the inputs. They just have the same, always have the same output. You can move them around. You can refactor your code so easily. They are so easy to test, nothing to set up, nothing to tear down. Hey, guys, we should use pure functions, right? And then you have the Haskell developers on the side laughing and say, oh, of course, you can use pure functions. That's what we do all day long. And then you have other developers who've been around for a long time. They say, oh, come on, Haskell guys. We've had functions for a long time in the OO world. Like, if you look at the design patterns book, notions of functions are there. Maybe they are called commands or actions or template method, but those are kind of functions is these guys, right? And even in the JDK, you have a comparator, callable, file filter. Those are functions, right? So come on with your functions. Well, those are kind of functions, but what they are not is first-class functions. Things that you can really take and that are generic from A to B, and you can take and move around and pass to other functions. And this is what we need to create software. And this is so kind of obvious that now you have, if you want to have a nice collection library, even in Java, the situation had to evolve. So if you want it's very natural to take a collection of things and map it to transform it to something else, filter it, removing duplicate elements, and so on and so forth. So, and something that has been done in functional programming like forever is now coming to Java in that sense. And the missing piece for this to even work was to have first-class functions that you can pass to map, that you can pass to filter, and so on. So it was kind of inevitable that functions would come to Java because we want to use those nice collections. And, well, now we have a syntax for it. I think in Haskell it's even easier and better and more understandable just because, I mean, that's the language that's built around the mere idea of functions. So I would just prefer using Haskell, but I'm really glad that those things now exist in Java. One interesting thing that you see when people start talking about functions and things and changing stuff around is you have this kind of advice, oh, by the way, don't mutate stuff. And the Haskell guys say, yeah, don't mutate stuff. We never mutate stuff. You don't need to mutate stuff, or at least if you do it, you can do it in some very controlled ways. And this is not a very new advice. So I don't know, I've been to a software conference 2 months ago where one of the talks was, again, over and over, how to use immutable objects and what kind of value they bring to your software. And you can find blog posts on the subject and even books by Josh Block on how to properly program with Java. They start with this advice. As long as you can, use immutable classes, right? And it has all sorts of benefits in concurrency, I mean, in understanding what the software is doing and so on. So what does this all mean? Is that functional programming in general, Haskell in particular, are teaching us a different way to program. Like we can use pure functions to program, to create some data, to transform it, and then to consume it. And I think this is a trend that's kind of very profound. So not only you see this trend at the level of the programming languages, but now we start seeing this trend more and more at the system level. So if you read a blog post like this one by Martin Kleppmann about turning the database inside out and basically how to get away from this idea of a database being a huge mutable object into being a stream of things. And he's taking everything that's, I really encourage you, who has read this article before? Maybe some of you? Wow, good. So he's really looking into all the properties that a database supports, like indices and so on, and, and explains how we can do this with just pure streaming and pure transformations. So I think it's the same phenomenon we're just seeing at a different level. Now we need to talk a bit about data. We've seen that functions are quite useful. And there seems to be a new concept here, which is just pure data that is being worked on and transformed and produced. In a way, this is not such a new notion. I mean, in Java, you had words like POJO, plain old Java objects, or DTO, data transfer objects, or value objects. All of these concepts are here to define some dumb data, like a struct in C, just holding some values with no methods, with no behavior associated. It's not really an object. And people are starting to realize that having dumb data is super useful. And it's so useful that in Scala, it's supported inside the language. So in Scala, you have case classes, companion objects. You have this in Kotlin as well. You have data classes. And, well, in Clojure, you have maps and lists, so everything goes. It's like, well, pure data. And it's coming up to Java, too. So this year, blog post by Brian Gott saying, oh, guys, I think we need it. It's super useful to have pure data, ability to create data easily to describe the things we are manipulating. The current situation in Java is not satisfactory. Too much boilerplate to do simple things. And funny thing, there's a follow-up to that post 2 months later saying, oh, by the way, maybe we should introduce a lazy keyword because there are some expensive computation that you can derive out of this data, but maybe you don't want it all the time. So maybe it should just be lazy. And again, I think that's the influence or the kind of inevitability of functional programming and laziness that you can see being at work here. And again, I think the situation in Haskell is so much easier. It's very easy to declare data types. So the top example is Haskell. The bottom is Scala. Scala, there's maybe a bit more ceremony, but just to show you that being able to create data types easily in your program is really useful. And once you have data types, you can do things that are even more useful. So this guy is Steve Yeager. He was working at Amazon at the time, and he had a blog post where he was describing an internal software programming competition they had at Amazon, and he said, oh, those guys using Haskell, they came up with a crazy solution. So in just one line, they can take a list of lists and extract just the second element of each sublist in just one line, and then have a complex condition about those elements and solve the problem. That's great. And they are using pattern matching. Pattern what? I mean, it was the first time in my life that I heard the term pattern matching. And it's a very natural complement to having data structures that are possibly nested and so on. You want to be able to easily extract parts of those classes. So Haskell people have been doing that for a very long time. But guess what? It's coming to other languages because, again, it's a kind of a natural consequence of just having data. So you have it in Swift, you have it in C#, and it's coming to Java as well, right? So if you think as Java being kind of the old grandpa, never evolving, yes, it is evolving and getting all this influence now. It's also not an easy problem to solve because data can take many shapes in your languages. Pattern matching can be something that's tricky. And I mean, in Scala, we've had bugs in the pattern matching algorithm for a long time. So that's something that even in Haskell, there were still some developments like 2 years ago, some major developments on how pattern matching was executed. So, but it's good, it's really coming. So what we can see here is that we had a world where we had objects everywhere. And this is how I've been presenting with, presented objects. Like you have an internal state that's hidden, that's well encapsulated, and you have methods on top of it that are like hiding that state and possibly changing their behavior depending on the internal state. And those objects are communicating together. So that's how I was presented that thing. And now we see a world where functions are extracted on one side, data is extracted on the other side, and we can actually program quite well with those two things extracted, and immutable data and functions. So more and more, we are kind of moving away from this idea of OO. And I think one of the fundamental reasons why we are moving away from this idea of OO is that it is hard to build systems with pure OO when you have like mutable internal state like this, because effectively this is a small state machine, having possibly different transitions, different states, initial, final, whatever. And if you put lots of those state machines together, you have a bigger state machine, which is even harder to understand, control, and debug, right? And basically, in passing, this is one reason why I don't feel comfortable with actors, because they just embody a larger state machine where I feel it really hard to understand what's going on. Like, behavior is more like emergent rather than really defined. Not that saying that you never need state machines, but programming everything based on state machines feels very dangerous to me. And then there's another place where OO was very dominant, and like in the 80s when OO was like started as the new thing, it was like user interface, right? Graphical components, they're all about small objects communicating together, exchanging messages, subscribing to each other, and so on. And I think we're also moving progressively out of this vision of the world, right? Just because it's hard. It's hard to have all these states all around. So in Haskell, you see some crazy concepts around how to model behavior, events, and have full libraries built on this idea that having a data structure that's going to evolve a long time. That's a domain that I don't know really well. I'm not a front-end developer, but everything that I see about Redux, which is kind of managing state, things like Cycle.js, where you carefully extract the state to have it managed on one hand, like in Purescript, the halogen library, all of this is about taming state, right? Having more components be more like pure functions in one sense, and having states somewhere else being fed to the function and retrieved out of the function, just to simplify the UIs. And I think, again, all the frameworks, all the libraries are still toying with this idea of how to get away with OO. So does that mean that it's the end of OO? I don't think so, right? We are, as an industry and as people, we take forever to move away from things. And there's a natural inertia to software. When something is written and kind of works, it stays there for a long time, and I think it's good. But I can definitely see a trend that's heavily influenced by just having smart functions and dumb data, right? A different way of seeing the world, not smart objects. So I think that's what Haskell is kind of showing the world and pushing the world, right? But there's another thing. It's the world of types, the thing that was really missing when I was doing Ruby and Groovy. And Haskell is showing us that we can have very good story around the notion of types. And it doesn't take very, very fancy types or a very, very fancy type system. With some very simple types and some simple data structures, you can already write some robust software. And there's this saying by Yaron Minsky, he's an OCaml developer, that we should try as much as possible to make illegal states unrepresentable in the software. And that's a good thing, because if you build your software such that there's no way to have an error, never, well, it's correct by construction, right? So that it's really great. So let me give you like 2 examples of this. So the first one, if you know that you have like a list of names or a list of identifiers, whatever, which is never empty, should never be empty. You can represent this using a special data type for this, like this one, like non-empty. And non-empty has, in the constructor, the only way to build a value of this type is to have at least one value A, at least one. And then you can have a list of other arrays, and that list can be empty. But by construction, you will have at least one. So there are things that you can do very confidently. You can take the head of the list, always guaranteed to succeed. Never have to check anything. By construction, it's fine, right? And there are things you cannot do. You cannot filter. Because if you filter that non-empty list, well, it might be empty eventually. So filter probably return a list and not a non-empty list, right? But there's a well-defined API of what you can do and what you cannot do. And this data type itself is giving you lots of guarantees. But you can extend this idea to other business processes or other technical processes. So I did a talk a few years ago showing how I use very similar ideas to encode the process of migrating some data from S3 buckets to Hadoop cluster, or possibly before to an EC2 instance, synchronizing the data and running some computations, sometimes on the Hadoop cluster, sometimes on the EC2 instance, but never on a S3 bucket, because that doesn't mean anything, right? So there were some combinations that were like forbidden. And by using case classes in Scala, I was able to like analyze all the different possibilities and just rule out some of them that made no sense. And if that makes no sense, I stop my process here and I say, it makes no sense. But if that makes sense, I have all the information I need to go to the next step. So maybe you can have a look at this presentation if you want to know more about the details. So with types and simple data types, we can already do a lot to make our software robust. But we can do more. So do you know who's this guy? Raise your hand, please. Not a lot. He's not going to like it. Maybe you know him better with his secret identity. He's a super lambda man, right? So this guy is Philip Wadler. And Philip is one of the original creator of Haskell, of the Haskell language. And he's been working on many, many other things. And one of the things he's been working on is bringing generics to Java. Because in Haskell, when you have a list of A's, you have A's in your list. You don't have you have specific A's. You cannot have a list of objects like in Java that's you don't know what it is. I have a list of shoes. Maybe I can put an apple in my list of shoes and it's fine. And when he realized that it was the case in Java, he was really pissed. Like, we should do something about this. We cannot let the world with a major programming language with no generics. That cannot happen. So he started doing something about it. And it turned out to be surprisingly hard because in Java you have subtyping. And then in Java, when you have a list of fruits, can you put an apple or an orange inside the list of fruits? Yes, I think so, you can, because you have a relationship between fruit and apple, right? A subtyping relationship. But it's kind of complicated, and that leads to new words that you need to learn about covariance, contravariance, and when to use one or the other, and what does that mean precisely, right? So generics in Java are kind of complicated in terms of type system. And for one reason, that's because we have subtyping. And subtyping is hard. And that's one of the messages I want to bring today, because subtyping, when you do OO, subtyping feels like something that's very, very natural. Like, I don't know, a circle is some kind of geometrical shape, and that's it. And I can derive useful information from this. And there are many things we think we can represent with subtyping, but actually it's not that easy. And I want to choose one or two examples of when it's getting in the way. So one of them is generics, where it makes generics a lot more complicated. We have lots of situations in Scala where subtyping makes the situation harder than it could be. But it makes also the language harder to make nicer, if you want. So in Java, people started realizing, especially if you compare to Ruby, Clojure, or whatever, that the language is quite verbose. So what can we do with this? So people started introducing the diamond operator to remove the amount of boilerplate. And that was already a good step. And the next step coming up in Java 10 is to have this new var keyword, where you can, given an expression on the right having a special type, you can deduce what's the type of your variable on the left. And that's good. It has all sorts of limitations, so you cannot put null on the right. And I mean, you need to read the spec. There are some limitations with this, but that's going to definitely reduce the amount of boilerplate you have in Java. And I mean, Haskell here is definitely showing the way, because Haskell is a language where the types can be like beautifully inferred. The expressions can be very, very polymorphic in terms of their types. And now Java is thinking, oh, maybe we should do a bit of that as well, because otherwise people will be really fed up by writing types all the time where the compiler should just be able to infer them, right? One issue with inferring the types in a language like Java, and in actually any language with subtyping, is that there's no good algorithm to do this in a general way. It's a hard problem. And it's a problem that was thought to be almost impossible to solve until very recently. So like last year, there was this thesis by Stephen Dolan where there are some new leads on how to do maybe better type inference when you have subtyping. There's some new ideas on how to make it tractable and just practical. But you might not see this in Java before a long, long time. So yeah, I just want to make you think about subtyping. Maybe it's not that easy, and maybe it's not that obvious. And what Haskell is teaching us is that you can program full systems without ever needing subtyping. Never, ever. So that's not something that's going to block you in your daily life as a programmer. And one reason why it's not blocking you is that Haskell has a great capability for abstraction. And you see this now coming more and more to the mainstream, if you want, with blog posts like this, like monoids for Java developer. And what is a monoid? So raise your hand if you know what a monoid is. OK, so I'll say it for the rest who didn't raise the hand. It's like things you can append together, right? I'll give you some more examples later. And monads, another thing that seems like an abstract concept that's actually very useful. And it's so useful that now it's even supported in Java in some libraries that you can use inside Java supporting those concepts. And it's even better supported in Scala because we have cats and ScalaZ, two functional programming libraries. And even in a very recent language like Kotlin, now you have a functional programming library called Arrow supporting the same concepts. So maybe they are kind of useful, right? So if you have a new programming language and the first thing you do is start to implement those things, maybe that's because they have some usefulness in them. And one thing that Haskell brought to the rest of the world in terms of abstraction and representing those concepts is this idea of a type class. So I was a bit annoyed by just the name type class when I started, because type class was nothing like a class in an OO sense. So if you think about the word type class, it's more about being able to classify types, to be able to say which types have which capability. So some types, they can do some things. So a type class is a way to classify them, right? Let's see an example, the monoid example. So a type that has a monoid instance is capable of appending two values together and getting a new value. And it also has a magical empty value. And if you append that empty value to anything, it returns that first thing all the time, right? And you have many, many types that have a type class instance for monoid. For example, int. So the append operation is just plus, and the empty value is 0. But you have strings, because you can concatenate strings, and you have the empty string. But you also have lists. And lists can be appended together, and you have the empty list. And this one is even more interesting, because actually you don't even care what's inside the list. You can always do it, regardless of what's inside the list. So it's kind of nice. So what can you do with this? What kind of useful things? OK, now you have a new abstraction. That's nice. But can you do useful things with that? Actually, it turns out that you can. So you can, for example, describe this operation, which is how do you reduce a list of elements to just one single element? And what do you need to know about those elements to be able to do it? So actually, you just need to know that that this type A has a monoid instance. That's the only thing you need to know. Because if the list is empty, you return the empty element. And if the list has at least one element, you append the first element to the sum of the rest. And that's it. So now you have one function that's described for many, many types, actually all the types that have a monoid instance, that can be tested once, reused forever. That's probably going to be correct forever. And then you don't have to recode it all the time, right? So it's a huge win in terms of productivity, to be able to understand where those concepts are, where do you have monoids, because then you can reuse lots and lots of machinery. So you learn it once, it has a strange name like monoid or monad, and then you see it everywhere. And you're like, oh, I'm enlightened, I see it everywhere now, it's cool. And then you learn new words like that are even scarier, like higher candidate types. And you learn that in Haskell you have higher candidate types, and you think, oh, I have something more to learn. Why? Why is that? But it's actually quite useful. So let me try to explain. So when we program, we use list of A's, like we can have 0 or many elements. Option of A, maybe we have one element, maybe we have nothing. Future of A, I will have one element, but in the future. Either A or B, and okay, maybe I have my A, otherwise I have an error, and that's B, and I probably need to stop what I'm doing. All of these types, they more or less look the same, right? They are more or less an M of A. And all of these types, they support a useful operation called flat map, which is kind of the main operation from this monad thing, the flat map operation. If you take an M of A, and if you have a function going from that A inside the M, giving you an M of B, then you get an M of B. And this is a very useful function to have. And being able to recognize these concepts and this situation in the wild is super important. And if you don't do this, you open the door to so many issues. So one example. So flatten was not really flatten when it was proposed 8 years ago. And now it conflicts with promises and whatever, and it's really strange. And well, maybe they have to rename flatten to smoosh, because just because people are scared of the word monad, don't really want to recognize what the monad is and just write it down. And you have the same situation in Swift. Different notions of flat mapping, depending if you are on a sequence or an optional, and depending on what you're flat mapping onto. And then, oh, problems arise. Because actually, there's only one good flat map, the one that's coming from the monad instance, right? So it's very useful to learn about those concepts and just being able to recognize them. And it's also useful as a programming language to be able to talk about those types. Because in this situation, the type that has the property of being a monad is this M here. It's not the A, right? And the M is a type constructor. Like list is a type constructor. List, if I give you an int, you return me a type, which is list of int. If I give you a string, give me a type, which is list of string. So talking about those types, M, as an independent thing inside the language is a useful thing to do. And those are higher candidate types. That's the weird name. And it's so useful that people doing type classes in Kotlin, I mean, they had to evolve the compiler just to be able to talk about those types, right? So they introduced higher candidate types inside Kotlin because it's a useful thing to have in your programming language. It's something that Haskell has been having forever. So showing the way, showing how to do it properly. And it turns out that you can even do it in Java. So using apparently annotation processors and all sorts of underscore magic, which I don't even want to know about, you can describe a monad in Java. That's kind of amazing, right? So what Haskell is teaching us is that there's a full world of types that we are progressively discovering because they are kind of useful, and that we might as well do an explorations for ourselves, like have a look at Haskell and what it's proposing. So first of all, it's telling us that subtypes might not be so useful and might be kind of problematic in some situations. Generics, yes, definitely kind of cool and useful. Higher candidate types, we are slowly recognizing that having higher candidate types and being able to talk about those types is something that's super useful. But guess what? There are more. So for example, rank n types. So rank n types are, that's the thing, the first time I heard about that, I thought, do I ever need this? Right? Never. And I forgot about it. And then I realized one day, programming something, how do I even express that? Oh, I need a rank n type. This year, I think for the conference at ICFP, there's a full paper written about, the title is strange, it's called Ghost of Departed Proofs, showing how you can model very nice APIs by using those types. And APIs in the sense that where the user can check in, have the preconditions for calling an API checked automatically if you want by the compiler. For example, if you have a hash map, and by construction you put something inside a hash map, it's really silly to have to, when you want to extract that same thing out of the hash map, to get an option back. Because you know that you've put something before in the hash map. Why aren't you able to extract it right away? So they show how to use those rank n types to make sure you can always, for example, extract stuff that you put in a hash map in a very safe way without ever having to call option.get or something that's ridiculous. But then you also have existential types. Existential types are very useful at information hiding. So I give you a value of a given type as an API. You don't have to know what the type of the value is. you don't really care, actually. You can use the value to do some stuff, and maybe later on you can give me the value back. And I know that because it has the type I gave you, I can use it back. So that's a very clever way, a nice way of just hiding information, making, again, our systems more decoupled and more able to evolve independently, which is something we want in large software systems. And then you have the whole world of dependent types, right, where the types can even depend on actual values and have specific, and you can do computations on types and so on. And I really encourage you to have a look at a language called Idris, which is a derivative of Haskell, if you want, where the syntax for just using those dependent types is a lot easier than using Haskell. But it's going to blow up your mind, definitely. Have a look at it. So far, we've seen that functions and data are coming to us, like mainstream developers. Types are coming to us, like better type systems. They really have some value, and we need to learn how to use them properly because they make our software better. And Haskell is also showing us some great libraries that are also influencing the way we build our libraries. So many Scala libraries nowadays are just direct ports of Haskell libraries. I mean, the F library I did in Scala was just a port of the F library of the F paper. I just ported it to Scala, and I suffered hell because it's harder to implement in Scala. But many libraries go from the Haskell world to the Scala world nowadays. So let me highlight a few libraries for you. So everything that you see in CAT or Scala Z more or less comes directly from Haskell in terms of the base Haskell library, like traverse, applicative, monad, monoid, all of that. You get it from there. But there are other libraries. One of them, which is great and almost inevitable once you start having data that's nested, is lenses. So once you start having data that's nested and that's immutable, how do you modify something that's deeply nested without having to rebuild everything manually, which is very tedious and very boilerplatey? So lenses is the answer to this. And it's really worth spending some time just trying to understand that library. It's mind-boggling. It's built around just one idea of something called a profunctor, which is some kind of generalized function from A to B, but so basically where you can focus on some part of your structure, do something, and then get the result back. And it also solves a real practical problem. The other one is QUICKCHECK. And QUICKCHECK was kind of the revolution in terms of testing, right? So the first revolution maybe was just, hey guys, we should write tests. So TDD, all of that, because not everyone thought that tests were useful at the time. And the second one was, okay, maybe we can be even better and start automating a bit more and do some data generation and write some properties that's supposed to pass all this data that's being generated. So that's pushing your testing game at the brand new level. And there are clones and other ideas now based on QUICKCHECK in the Haskell world. And I can definitely predict that this is going to be translated in Scala and Java and other languages very soon. Streaming libraries are super interesting in Haskell. Streaming is an interesting problem. So at first, it seems kind of easy. So streaming is the situation where you don't want to accumulate all this data in your memory because it's just finite. You need to process the elements one by one. OK, problem solved. But it's actually harder than this because you need to handle resources, when to close your file, the file you open in case of a crash and stuff like that. You have concurrency issues, you have composition issues, and so it's actually not trivial. And there are like at least 4 or 5 very interesting streaming libraries in Haskell that I really encourage you to have a look at. Everything that's around concurrency in Haskell is interesting. So you have this async library, and you have the software transactional memory library. I haven't done lots of concurrency programming, but I can definitely say that I'm a lot more confident programming anything concurrent using Haskell than using Java and threads and like low-level stuff like that. I mean, the last occurrence of me using concurrency was just saying I had a map function to apply a function repeatedly, and I said, oh, actually, it might be better if I do it concurrently, and I wrote map concurrently, and it worked. So. When that's simple like this, just use it. But I don't want to leave you the idea that Haskell is like this perfect world and that you should switch your project today to Haskell and that everything is going to be nice. First of all, because It's like a new programming language. There are lots of concepts and an ecosystem to learn about and so on. And there are lots of things that can be improved in Haskell as well. And I think that other languages can also bring more to Haskell in terms of the community and libraries and so on. So first of all, Haskell doesn't really have modules. So it has like namespaces, but not really this idea of modules that are a bunch of closely related functions that you can move around and kind of keep some kind of consistency between those functions. And for me, it was a big no when I started using Haskell. It was really, really annoying for me not to have modules. So effectively, on my projects, we implemented a small module library to have, based on records of functions that we can move around, that we can mock, that we can replace, and so on. And this is not baked in the language, and I really regret it. I especially regret it because there was this great paper written, I think, in 2012, presenting first-class modules for Haskell, solving the problem once and for all. It was a great paper containing, even they had an implementation for it, and I don't know why it got abandoned. So it never made it to the language eventually. So I hope this is going to come back one of these days, because I would like to have this in Haskell. There might be a situation with garbage collection, not one that I've had personally, but there are some people who try to push Haskell to its limit in terms of garbage collection, and latency was not good enough for them. There are some solutions now, these things called compact regions and stuff like that, where you can more or less manage your memory yourself, but it's not really easy to use, and I really wish we could use that. Especially because in Java land, for example, you have a lot more, I mean, the people are working very actively on GC. And in Java 10, you have even more parallel computation for the G1 collector and so on. So I think I would like more work to be done by the Haskell team on this. The record situation is really bad in Haskell. So for the record, a record in Haskell is a data structure where you have names for each field, right? It's a bit like a case class in Scala. You have names. And the trouble is that by default, those names are actually functions. There are functions taking your record and extracting the field value. And the functions, by default, if you have two records with the same name for one of the fields, they just clash. They are in the same namespace, they clash. So there are lots of solutions, right, to deal with this issue in Haskell. I really wish there was something baked into the language, again, once and for all, so that for when you are a newcomer, you don't have to read 10,000 blog posts to understand how to deal with this situation. That's not pleasant. IDEs are also not so nice, so everyone has its own version of Vim or Emacs with this plugin and that tool and so on. I've been trying to use IntelliJ in the past. I haven't been so successful. These days I'm using Visual Studio. I can see a trend of many languages going to Visual Studio because of this LSP initiative, like Language Server Protocol. And I think probably we will see more languages coming to Visual Studio, and I hope that this is going to bring some more momentum for Haskell in terms of development and better IDE and better integration of all the tools. Because you have some great tools in Haskell, like, let me just give you one idea, like Google is the Google tool for Haskell, where you just you write the type of a function, and it gives you across all the libraries all the functions having the same type, or almost the same type. So it's a very great way to search for some code which you think you need, and it might be present in a library out there. And this tool should just be nicely integrated in your IDE. So I think that's about it. Functions, data, types will make a better world. They are coming to you, I think, whether you want it or not. But I really encourage you to have a look at Haskell and tell me what you think about it.
We have a question immediately.
So obviously there are lots of things that I miss from Haskell in the languages that I actually work with. But today I would say that the biggest thing that I miss is servant, or something similar. My question is if there's anything like that in Scala that you know, or in any other language that yes, you would say it's equivalent.
So in Scala you have, so we've been using row on top of HTTP4S. and it's been working quite well. And one of my team members even did the upgrade of Rho to the latest version of everything in the Scala world. So yeah, that should work. That should still work. And the cool thing we had was effectively the ability to generate the Swagger file automatically, and it's in our test suite. Every time we change a piece of code, if by accident we change the API, a test will fail, and that's really cool because then we know, okay, is it expected or not? Maybe it's expected, and then we can publish the new API. So yeah, so you can use Rho, but there are other initiatives in Scala. I think there's something called endpoints, and we had a presentation at the Type Level Summit in Berlin about another project. Sorry, I don't remember the name, but look for the Type Level Summit. So yes, there are things, and actually, servant Swagger is not that good. It's we need to work on that. So yeah. Oh, you did some comments on it? Okay. Yeah. Okay. Yeah.
Servant is nice, like the basic library is nice, but the things around are still quite bad.
Yep. And also in terms of implementation in Scala, I encourage you to have a look at Rho, just because it has this crazy data type, having 40 type parameters, one for each HTTP error code. It's funny.
Two small questions. The first one, how many Haskell developers do you have in Zalando?
Oh, good question. So we have a Haskell guild of, I would say not that much, maybe 25 or 30, and my team is like around 10 people. And we have even some legacy Java now. We have some legacy Scala, and everything new that we build is in Haskell. So yes, we are still a small team, but we have a technology radar inside Zalando, and Haskell was recently promoted to trial, which means we can use it in production. So my team showed that it was possible to use Haskell in production to write microservices that are reliable, and so now we hope to expand this. Yeah.
Another question could be a little bit broad, I think, but our team did a couple of attempts in order to evaluate like Haskell as a platform or like wherever we can build something useful on top of that. And normally, I mean, you would try to keep your code as pure as you could, but then, I mean, when it comes to like login, metrics, database, etc., there is a lot of I/O around.
Yes.
So maybe you can maybe you can provide any like recommendations, like general recommendations, how to test this stuff, how to combine it.
Yes. So I can tell you what we did was to build this modules library that I told you about. So logging is a module, metrics is a module, and so on. And you have so for any new module that has some dependencies, you have a constructor basically taking other modules, and you have some special type class instances where at the top level of your application, you can say, give me module T, and it's going to resolve all the dependencies and build all the dependencies for you and give you the thing aggregated. And if you want to mock one of these dependencies, you can use something called a registry, where you can specify that, actually, for this dependency, don't build it from scratch. I'm going to provide it to you first, right? And it's going to use that one. And this has another cool application, very cool application, I think, about QUICKCHECK generators. Or we are using hedgehog generators, where you can, because one issue we've had with generators for complex data models was that in our case, we have articles with like shoes and has different colors and different sizes and different prices and so on. And if you have a generator for a shoe, and now you want a generator for a shoe, but where the price is always greater than 10, you cannot do anything except that rebuild your full generator, passing in a generator for price, right? But you can use the same idea we have of building modules for building generators to have a compositional way of saying, I want now a shoe that's, all my shoes, I want them to have the color red and have a price that's greater than 10. And I think we can also apply these ideas to JSON encoders, decoders. So yeah, that looks interesting, and that's what we've been doing.
Thank you.
Oof.
Hey, so you said that like functional programming is not really a good concept or not a new concept, right? It's been around for a while. And then at some point in time, we kind of all jumped on to the OO bandwagon. And it kind of seems that currently everything is going towards a functional way, right? JavaScript and everything is trying, and as you pointed out, Java too. Isn't this going to be the same thing? After all of the languages will be trying to do everything functionally with dumb data and very smart functions. Isn't it going to be the same thing, but now towards functional, whereas it was previously towards...
So is functional programming a fad? And what's next? So I mean, there are people already thinking about what's next. So there's a talk by Eric Meyer recently about actually the code should be written by a machine and using machine learning, and maybe that's code 2.0, where you just say, what's your input, what's your desired output, and it will figure it out. And there are lots of research about code generation and code synthesis that are really, really interesting. So that might be the future. Honestly, I don't think it's ever, I mean, I won't see this probably in my lifetime, but that might be the future. But regarding OO, I think maybe OO was kind of a conceptual mistake, or maybe a cognitive mistake, because it's very appealing to do OO. And I think the success of OO was that it's very appealing. We tend to anthropomorphize many things that we see around us, right? So you see a chair, it's like a piece of me, I can do things. No, I cannot really move, but I have a color and stuff. And we tend to think about things as objects communicating together. So it's kind of an easy way to understand the world. But it turned out that it's also a difficult way to build software with.
Aren't we going to go back to 10 years from now and then say that functional programming was a conceptual mistake because...
I don't read in the future, but I don't think so. I think the benefits of doing functional programming are so huge that it's... Yeah, I don't see us reverting back to O.
What's your take on something like spec in Clojure versus a strongly typed language like Haskell?
So I cannot tell. I haven't had a deep look at that. Maybe one thing I can tell is that some things are really hard to represent in types. So it's good to have additional ways of specifying things like preconditions and postconditions, and so I mean, you have things in Haskell like liquid Haskell, where you can say even more precise things about some values, like it should never be greater than 10 and things like that. So yeah, those things are probably complementary anyway.
Yeah. How do you do your deployments with Haskell? Are you using like containerized, or is it?
Yeah. So at Zalando we have a nice deployment platform, like CI/CD. So where you have an internal GitHub enterprise instance. Every time we push something to master, just a few file descriptors, it goes to the CI, and we have some pipelines, and then it goes to Kubernetes, and everything is deployed inside Kubernetes. So effectively, the only issue we had was like making sure we had pre-computed images containing GHC already and a bunch of libraries, because you don't want things to be recompiled forever all the time. It takes really a long time. So, and recently in our build platform, there's this concept of overlay, where you can even more easily specify what's your base, where you start from for your CI, and yeah, then you cut your compilation times.
Thank you.
I think that ended. Thank you very much, Eric.